Building RAG applications used to be a big deal, expensive, complicated, and slow. Early LLMs only ran through hosted services, logged behind subscriptions, and every time you sent a query, your data had to leave your system, which is not great for privacy. But that's no longer the case. Today, with the arrival of small but powerful models like Granite 4 and intelligent code assistants like Claude, you can build affordable, secure, and production-ready RAG applications in your own machine. Hello, my name is Eduardo Kaufman Malaga, and today I will show you how to build a local RAG application from scratch in just a few minutes. Let's begin. For our example, we're going to use IBM's Granite 4 Micro, which is one of the smallest open source LLMs available. If you want to learn more about Granite 4, watch my previous video. To run it locally, we will use Ollama. To download the model, we type in the terminal Ollama Pol Granite 4 Micro. Great. Now that we have downloaded our local instance of Granite 4, we're going to test it to see if it's working fine. To demonstrate how this works, we're going to use a Jupyter notebook, and we're going to use LangChain as a framework to communicate with the LLM. The first step is to load some libraries. Then we're going to set up our knowledge repository. This is a simple test, so we're going to put all the information in a single variable. These are entries about the Bridget Jones movies. And this is the same example that Granite 4 has in its documentation, so we wanted to compare the results. Next, we're going to build a knowledge store. To build a knowledge store, you have to provide your array of documents and an embedded model. We're going to use the embedded model from Ollama, Nomic Embed Text, which is good for small documents. We create a variable called docs that formats the document and the content using their titles and the content. And then we use FAISS from Meta, which creates vector stores in memory. Then we set up a retriever. This is what is going to retrieve the information from the vector store. And then we're going to create a RAG. We're going to use Ollama LLM to establish our connection with the Granite 4 instance. And then we create one function. It's called answer, and it only takes one parameter, the question. The way this works is using the questions, we use a retriever. This is basically identifying what portions of the knowledge store may have the answer. Then we format that variable to create a string variable, and we call that context. Then we build our prompt. Our prompt says you're a helpful assistant, use only the context. Then we provide the context. We just create it, and we pass along the question. So we're going to test this. Let's run this. And the question is, who are the possible fathers? Just baby. And it tells us there is Mark, Darcy, and Jack Quent, which is the correct answer. Now we're going to do something more fun. We're going to use Claude to create a full RAG application that reads a particular URL we provide and is able to answer questions based on the content of that particular article. So we're going to send a prompt here to Claude, and I'm going to explain what is my prompt. So I've tested this prompt a few times to make sure that it produces the right result. So I'm asking it to create a Python script to create a local RAG that reads a URL and creates a vector storing memory. It's similar to what we just did in the notebook. We're going to use Streamlit for the UI. It will use my local instance of Granite 4. It's going to use the class chat Ollama as opposed to what would you use here. We use Ollama, which is good for single interactions, but to have conversations, you need to use different classes. I'm specifying what I want to use for my prompts and messages. We're going to use FAISS for the vector store, the same embedding models, and I'm asking to create a logic to build standalone versions of follow-up questions. I'll talk about this a little bit after running a couple of examples, and also adding an environment variable to prevent some bugs. Claude has finished creating the code and asking permission to write, so I'm saying yes. Okay, it created the application, is describing the application, it used the right libraries, is implemented RAG against the URL, it created a function for follow-up questions, implemented RAG, and it's telling me how to run it. So I'm gonna use the command to start my Streamlit application. Okay, great. So I'm gonna pass here the URL entry of the Bridget Jones third movie. I'm gonna say load URL. Okay, it parsed the URL. So now we're gonna ask a question. Who is the father of Bridget Jones' baby? And we got an error. Let's inspect the error. Well, in this case, the error seems to be pretty obvious. It's telling us that using Granite 3.12b, which is not the model I asked Claude to use, we're using Granite 4 Micro. And so it's not finding the model in my local instance of Olama. So it's pretty simple to fix. So let's go back to Visual Studio Code and fix this error. Okay, let's inspect the prompt to make sure that we provide the right model. Yeah, we have said use Granite for Micro. Okay, so I'm just gonna copy the name of the model and I'm gonna update this line where we define which is the model the ChatOLAM is connecting to. Okay, let's save and rerun our Streamlit application. We load the URL. The URL loads it into our memory vector store. We're gonna ask some questions. When was this movie released? And that is the right answer. Let's ask another question. How did Bridget reconnected with Mark? And again, that's the right answer. One more question. Let's ask, who's the father of her baby? Notice I say her baby. I didn't say Bridget. And this is the right answer. Now, let's take a closer look at this section. If you remember, when I wrote the prompt for Claude, I asked it to include logic to generate a standalone version of each question, especially for follow-up questions. This is why this is important. When you're having a conversation, you rarely repeat all the context. You might say things like, what about that one? Or when did he do that? Relying on pronouns or implied references. That works fine when you're having a human conversation, but it can be confusing for a retriever model because the retriever doesn't automatically know the full context of the previous terms. To fix that, we ask the LLM to rewrite the question as a standalone question, one that is fully self-contained and includes all the context needed to understand on its own. That rewritten question is then used for retrieval, so the system can find the most relevant chunks of information and then generate the final answer. Now let's take a look at the file and see what is the code that was produced. This is the code. It was all produced by Claude with only one mistake. It included a section to create the standalone question. It was 232 lines of code. Now let's do a quick recap. In this tutorial, I show you how to download Granite 4 macro, run it locally on your machine, and build a fully functional RAG application for multi-turn conversation, all in just a few minutes using Claude. I hope this walkthrough helped you see the power and flexibility of small local LLMs and how easy it can be to integrate them into real-world applications. In my next video, I'll show you how to use Docling to create RAG applications that use PDFs as their knowledge source. Stay tuned for that.